This is combined gas law, simply because we will combine all the gas laws we have discussed so far. So we have Boyle's law, Charles' law, and Gay-Lussac's law. So Boyle's law is PV equals K, so meaning the product of pressure and volume is constant. In Charles' law, the quotient of volume divided by temperature is constant. In Gay-Lussac's law, pressure divided by temperature is constant. So in combined gas law, we'll just combine everything. So in the numerator, you have two variables, pressure and volume. So you put it in your numerator, PV. And in your denominator, you only have one variable, which is temperature. So meaning PV over T is constant. So meaning here in combined gas law, only one is constant, which is your amount of gas. So pressure, volume, and temperature varies. Okay? So for combined gas law, our working equation is P1 V1 over T1 equals P2 times V2 over T2. Alright? So let's have our first problem. The volume of N2 at STP is 22.4. What is the new volume if pressure changed to 1.2 atm and temperature to 88 degrees Celsius? Okay? So again, it's important that you follow proper solving format. So let's have our given and required. For our given and required, I will write all the variables. So we have P1, V1, and T1. Here we have P2, V2, and T2. Okay? So let's have our initial condition first. The volume of N2 at STP is 22.4. So STP, so you already have two given there. So you have your standard temperature, which is 273 Kelvin. And you have your standard pressure, which is 1 atm. So we will not consider them as our SF. Volume 1 is 22.4 liters. Okay? So, again, you express your SF based on the given. Our P2 is, what is the new volume? So, V2 is what we're looking for. Change to 1.2 atm. So, that is our new pressure. And T2 is 88. Now, we have to make sure that our units are consistent. So per pressure, so we have no problem. Our units are both in ATM. For volume, so we assume that our answer will be in liters. However, for temperature, we have to be consistent. So this is in Kelvin. So 88 should be in Kelvin also. So you just add 273. So T2 is equal to 361. Okay? So since we know that this is combined gas law, so we will use our working equation, which is P1 V1 over T1 equals P2 V2 over T2. So we just substitute. Okay? So P1 is 1 atm. V1 is 22.4. Our T1 is 273 equals P2 is 1.2 atm, V2 is unknown, and our T2 is 361. Okay? So, by cross multiplying, so we have 1 times 22.4 times 361 equals 1.2 times 273 times V2. Okay? So, by algebra, you can just solve V2. So, that's simply 1 times 22.4 times 361 divided by 1.2 divided by 273. Okay, so our V2 is 24.6837 in my calculator. So we have to express in proper SF. So again, these are not given. The given are 22.4 liters, 1.2 atm, and 88. So it's best if we express our answer in two significant figures. So our answer is 25 liters. So this is our B2.